Alrighty, so Scott's going to present his latest work on the API management front. Take it away, Scott.
Okay. Yeah, I don't know how many people were here for the last time I did this, so I'm going to start over, basically. But I am going to run through it pretty quickly because there's a lot to cover. So let me go ahead and present, I guess, my screen here. Go ahead and do a present on this. Okay, can everybody see that?
Looks good.
All right, awesome. Okay, so very quickly, so the goals for this is to provide a way of, a common way of allowing people to enforce, install APIs to Istio and enforce authorization authentication around them, as well as policy and telemetry. So there's a number of things that go into that, but the other real goal is to ensure that it's minimally opinionated and vendor neutral, so that you can have you can still plug in whatever you want into this system, and it doesn't become onerous to the provider. Oh, and also that policy on authentication control will remain with the Istio operator, as opposed to being transferred over to the API provider. So you'll see how that works as we get into it. Very quickly, my definition, working definition of an API is it's a client-facing documented application interface that's accessible to clients via API-specific credentials, and incorporates a named set of API operations within that API. And this matches up pretty well with OpenAPI and gRPC, as we'll see in a minute. So OpenAPI specification, very quickly, most people are probably familiar with it by now. It's just the very common, it's essentially de facto industry standard way of creating or documenting a REST-like API.
It's not an actual standard?
That's a good question. I don't know if there's a standards body that's in charge of it right now. I mean, like a completely independent standards body. It's definitely, it's not proprietary.
Yeah.
There are multiple companies working on it, but yeah, I can't answer that.
Okay.
I bet Jeremy.
Sorry?
So I bet Jeremy would know. Whitlock.
Well, he's working on the standard, so yeah. Just a quick example of how an OpenAPI document looks like on the left there. It's a YAML or a JSON document. It just documents the OpenAPI standard, some information about it, where the servers, the paths, the operations. Each operation is required to have a unique ID, and we'll take advantage of that. So between the paths and the operations, that's what we're really looking for at this point. Potentially in the future, there may be opportunity to take advantage of schema, looking at schema validation, things like that, but we're not looking at that right now. We'll wrap that in a CRD. So it's an API definition kind, has a name, and then the spec can just be thrown into the descriptor wholesale because it's also YAML.
And where did we land now on the oversized OpenAPI specs?
So right. I mean, that's basically going to be a question of linking. I don't have that spec'd out. OpenAPI does have a mechanism to allow linking to other documents.
Okay.
By some sort of ref.
Okay, so you'd end up creating many CRDs and link them together.
Yeah, we would have to have some explicit support for that in Galley, I guess.
And the limit is 10 megabytes for CRDs, is that it?
I think the default's a little bit less than that.
Okay, that's a pretty big frickin' YAML file.
Yeah, that there are some pretty big ones out there too. So I imagine the chances of us hitting that are actually pretty high.
Okay.
gRPC, we should probably all be familiar with this. It's also industry standard CNCF project, and it is language and implementation independent. RPC spec, standard hello world in gRPC looks a bit like this, where you have a service and messages. And so you can see both of those basically can work within the context of what we consider an API, which is going to be based on the ability to look at a host and a path. And gRPC API definition looks a lot like what we're doing in Istio right now for adapters. Basically, you just compile it, throw it in the descriptor, and then we can decompile it later or introspect it, or whatever we need to do. So that defines essentially the client view of an API, where you have an API, you have a client app. I mean, this obviously expands beyond just the Open API or the gRPC spec, but provides the context around it, where generally you have an API that is accessible by a client app to a client application via an API credential. It's published by an API provider, and it has a set of operations. Pretty straightforward. The next thing we want to do, though, is add to that the backend implementation of how we actually manifest that. So what we're creating here is an API manifestation, which provides policy and routing and authorization requirements. And yeah, we'll see how that works as well. So an API manifestation then is based on client credentials. It declares the backend implementation that will be used for an API. So it has to provide authorization requirements, any necessary policy checks, and a workload endpoint of how it's actually going to be the functionality be implemented. I think this is basically how we're coming down on this, is that everything is going to be handled within Galley instead of it generating CRDs outside of Galley. That way Galley can take advantage of separation between the CRDs and the actual protocol. Sorry, what's the name of the protocol that Galley uses?
MCP.
MCP, right. So the MCP has a clear separation between our CRDs, and we don't get into a situation where it's confusing all this generated stuff that goes back out into the API server. Instead, it just goes out to Mixer and Pilot.
So there's two things I wanted to mention here.
Okay.
So Louis been pushing that we keep clear architectural separations between components and try to not put more things in the core, because we're already having problems. We already have a lot of customers that say, I just want this feature. Why am I paying for all this other crap?
Right.
So that might push us towards more like, don't put it in Galley. But to address the problem of not putting it in Galley is you could also have a separate controller that is reading the original CRD and pushing MCP down to Galley. So you're not pushing stuff back into the API server. You could be directly pumping into Galley.
Right. Yeah, and I'd like to see Galley more modular so that you could have plugins come into that and be able to do that kind of work.
Yeah, so it's interesting whether it's easier to do it on the outside completely or to add a plugin model in Galley to orchestrate it.
Yeah. Well, I would make the argument that Galley is part of Istio, and I understand breaking things out of Istio, but at the same time,
so I think I'm gonna kind of challenge that word a bit, right? Because so we can make Galley a bit more modular, right? And we can make it consume MCP, but I think you end up creating a hole in the system that suspiciously looks like Galley. So any replacement implementation, will be 80% Galley, right? So if you have this kind of modularity to begin with in the system.
I don't understand that.
So let's imagine company Acme wants to do something similar, right? So they don't want to use Galley, they want to use Pilot. Okay, so we are trying to modularize the system.
No, that's not what I was describing. So if you assume in a system that has Galley, do we want to augment Galley by having API management functionality in it, or try and keep it out? So that part is more modular, that somebody that wants to use Istio security features is not paying a cost for having API management in there.
What is the cost of having the API management features in Galley that they will be paying?
Largely, I think it's largely an architectural discussion of I have this separate box that only does this. It doesn't have these other bits. I don't know. I'm more worried about the runtime cost of Proxy than I would be in Galley.
Right.
But in an a la carte model, that I could pick pieces of Istio that don't pull in other things that I don't care about.
Right. So which if we can, so I don't want to rat hole on this front. I think this is not about this particular topic at hand.
Yeah.
We can discuss about this later.
Right.
Yeah. It sounds like a good discussion to have. Let's get through this, and then we can see how much. I mean, really, the purpose of Galley here is largely the same as what it was, except we've added the ability to interpret APIs, right, into the same kinds of things that we already create. So
yeah, so it's not a big divergence.
Right. Okay, so let's just walk through an example then, because I think it's the easiest way to view this, and you can look through the document later for more detail on this. But we start with the API definition, as I said before. Looks exactly like you'd expect. It dropped the hello world stuff into the API definition, and so we have a path /hello, an operation get. It has an operation ID, say hello. Pretty straightforward. So the first thing that has to happen is we have to have a gateway into the system. The API producer is going to declare this, but the Istio operator actually maintains the gateway. So the bindings are here as part of an API manifestation. The producer would say, which gateways it needs to be bound to, the hosts that is bound to, and then the API definitions is just a list of which API definition CRDs, the names that this applies to. Sorry, and so it's a one-to-many. You have an API manifestation may apply to multiple API definitions. The Istio operator still has to maintain the gateway. And the reason for that is because it seems like a logical point of separation there, that the Istio operator wants to maintain the gateway and authentication into the system. And so instead of trying in take one, which is a much more complex view of this, it tried to interpret the information and create gateways and things like that. It never felt right. And so we're backing away from that. Instead, the Istio operator determines exactly how the gateway operates still. So once the communication would be when you publish an API, then you would inform the operator. But once it's published, you have full control of it within the API definition. Galley would generate the equivalent of a virtual service, right? And this would be taking the API manifestation information of the gateways and hosts and basically throw it in there, as well as the matching information for the URIs for the paths. And it would basically route nowhere. And we'll see, why that is in a little bit, but mostly because it can't route anywhere until it actually knows who's making the call. So speaking of who's making the call, we need authentication, authorization, and classification of the APIs. So the API producer is going to declare a binding to the gateway for the API, a binding to the host names, and the authorization to the API. Now the Istio operator maintains the authentication part, declaring which authentication methods are valid for Istio. And then the API producer merely takes advantage of that information, the claims that get generated from that. We'll see how that goes. So an API manifestation as part of its authorization information, and this may need to be, this is probably a good place for additional discussion too, is exactly how we want to do this matching. But for right now, a simple example is to do it allow, and it just has matches for claims. So the claims that come in from like a JOT token and an API key will be the same kind of manner. We'll issue a set of claims. These claims are passed down from authentication to this classification filter. The classification filter will look at these requirements. So if it requires an issuer of helloworld.com and it requires a scope of employee read, if it matches both of those, as well as the say hello operation information, which is that path and host, then we have a match, and we have an API and an API definition and an API manifestation, and we know the operation. So if we know all three of those things, then we can go forward into the system. If it doesn't match, then it will look at the next manifestation that matches that operation. So the Istio operator defines the authentication. As I said, this is very familiar. The key is that your targets have to match the information. It has to match both the incoming, whatever the incoming host is. Oh, I'm sorry, this is authentication. I'll get to the gateway in a minute. So it matches the target, the ingress gateway, so it can do the gateway. And then if you're going to do intra-mesh, which you can do with this this particular scenario, you also list the name of the actual service that you're hitting. So by doing that, it will require that a JOT token, or well, in this case, a JOT token, will be required to hit that service in every instance, and that allows then the API management system here to do its work. And as I said, API key will also be supported. That there's a different spec out for that that allows an API key to be translated like a JOT into a set of claims, or for that matter, any opaque token. So classification itself, API definitions can have overlapping hosts and paths. They can do that because we're relying on the API manifestation and its authorization to discriminate between them. So for example, you can have a gold and a silver API. They could share host and some paths, but then they have separate sets of policies for their operations that are set up by how you authorize those. And then the final discrimination, yeah, like I said, is done by authorization checks. And then basically the way that boils down is the host, the URI, the claims comes into the classification filter. As I said, it runs through the set of manifestations that apply, and then its work is done once it either defines the API definition, manifestation, and operation attributes, or it does not. If it does, then the rest of the API will work off of those attributes. If not, it's not considered an API, and it could either be blocked by RBAC rules, or it could be allowed to go through as a non-API call. Policies, very simple, actually, in this case. Right now, the operator maintains the policy library, the Istio operator. So I'll show you how that works in a bit. But the API producer merely declares that it's going to be used for a certain operation. So the API manifestation has a policies section, and literally the keys are just policy names that the operator set up, and the values for now remain undefined, but are open objects, so that we have opportunity for enhancement there.
So who's going to enforce these policies in your current design?
It'd be Mixer.
This is all a Mixer side thing. Okay.
Yes, yes. So literally what happens is the operator defines a rule like they normally would. They don't need a match at all, so that the rule would never actually fire, because the rule operates as a template. The rule has actions, response, header, operations, the standard kinds of things. So in this case, I created a rule that's inject API header. It injects it on the response. It just says X API response is true.
Cool.
Basically what Galley will do then, or whomever, it'll take this rule that exists, and it'll fill in the information. It'll say, okay, in this case, it has to match this definition, this manifestation, this operation for it to take effect. Oh, and it'll change the name too. It'll have to be some generated name. So that's a little bug there. But so it'll generate a name for it, and it'll clone and add a match. And this is potentially something also that we could enhance by allowing additional matches to be done, at the in the manifestation. We can, don't need that, I don't think, for first cut at this.
Okay, so I think I missed something. So you're saying what we're looking at right now, that's generated?
This would be generated, essentially, yes.
From the OpenAPI spec?
It'd be, right. So
okay,
we have inject API header listed as a policy.
Which
So
is
it's going,
that's hand authored.
which is what?
That's authored by hand.
Yes, that is hand authored.
Okay.
So that rule then obviously connects a handler to a template, right?
Yeah.
Okay, so we have all the information we need to call it, except for the match.
Okay.
So all we're doing is adding the match and
Okay.
saying, okay, we know it's an API call. We know it should be calling this policy, so do it.
Okay.
That's it for policy. For routing, so the operator is still in charge of deploying the workloads, the services, virtual services, or some operator is. It could be the API provider, but that's all low-level Istio stuff that has to be deployed, and then, or yeah, Istio and or Kubernetes or whatever, and then the API producer merely declares the routing to those workloads or virtual services. So as part of the spec, this is part of the manifestation, we can specify for the say hello operation a destination of hello world, a path of /hello world. These would just be, these would either so I have two sections there. One at the global level, saying that in general, everything goes to hello service port 5000. But specifically for say hello, I want to override the standard definition. So in API definition, remember our path said /hello was for the say hello. Instead, I'm going to reroute it to the /hello world in the hello world service or virtual service, if that makes sense.
Okay.
So it's just it's a way you can override. Now there's one little thing I still have to work out, and that is path templating. The idea there would be that at least in, I think we can do this in both OpenAPI and gRPC, and that is if you have named items in your path, that we could be able to pull those and then put them back into the path here.
Mm-hmm.
Now it only matters on override, because if it's not an override, that the path will just pass through.
Yeah.
And you don't have to change it, but we may have to figure that out in the case of overrides.
When you wouldn't want to be able to apply universal rewrite as well? Send everything to /old or whatever.
Oh, yeah.
And shouldn't you be able to also pull out a chunk of the path and pass it as a parameter instead?
Right, exactly. That's what I was talking about, path templating.
Okay, all right.
So it's less important than you might think, at least the global override, because you can literally create another virtual service that does that for you.
Okay, yeah.
Since this allows routing from the API to a virtual service, you have complete control. You can do everything you want in the virtual service as well. So you can have it go to 2 different virtual services depending on where you want to go.
Yeah.
So it could be a hello service old.
Okay.
But yeah, the whole path templating thing is something that I need to work through. So basically, the operator would create the service or virtual service that's necessary for the routing. So in this case, we want to take the host hello world on the gateway, hello world gateway. We're going to match and set up the destination going to the actual hello world service here in the port, like you would normally do with any Istio virtual service. And it's possible maybe the trick here is that the gateway does have to list, right, the host. So for it to come through the gateway, you have to have the host. So you have to update the gateway again to include this host. But once that's done, it's done, and you can move forward. And that's standard Istio as well. So it's not an add or remove on that. And basically the way this works is, so we already did our classification. We have our attributes, the definition, manifestation, operation. Those come into the destination filter. It looks up the information for that, and it just sets the authority and path so it can go on its way. And it'll cause a rewrite of the route. Or actually, what it really does is it clears the cache, so it has to recalculate the route. So all that is kind of here in this logical flow. There shouldn't be anything surprising in this. It's basically just goes through auth, policy selection, or sorry, yeah, that's mislabeled. So it goes through auth, through classification, route selection, and then policy enforcement, of course, happens on the target and then hits the workload. That's basically it. So you made it through. I can show one other thing since, well, if anybody has comments or questions first.
Okay, so again, on the topic of keeping piece of the architecture independent. So how much there's really not that much logic being added in the proxy proper, correct?
So in the proxy, there's two filters being added because it takes advantage of the authentication and the expansion of authentication to include opaque tokens. It has a filter for classification and a filter for routing. That's basically it, yeah.
Okay, and when you say filters at this point, these are generic. They're not. They're just generic Envoy filters.
Envoy filters, yeah.
So you don't need to be producing attributes.
No, you do. So they are Istio filters because they have to access the attributes. So there's two things. They do produce attributes and they consume attributes, right? So
yeah.
The attributes from authentication, the claims come through as attributes. So I have to access those in classification, and then in classification produces those three attributes. So basically it kind of operates as an extension of authentication in that sense.
Okay.
And then the routing part has to also access the three attributes that are created.
Okay.
The API attributes.
Yeah, so
that could be done through headers, but sorry, go ahead.
We'll want to figure out how to make this modular, because I think ultimately all this stuff is going to be compiled down to WASM.
Yeah.
And we just need to figure out how to inject this so it's not present on people's systems that don't want it. I think is achievable.
Yeah. I mean, I expected that it would basically do like Galley does or Pilot does today, and that if you're not using it, it doesn't inject it, right?
Yeah.
So if you don't use authentication filter isn't there. So it'd just be the same thing. Now, eventually, with, like you said, with Mixer v2, things may be changed around a bit. Yeah. But you know, in the current architecture, I would view it as operating exactly the same. Either the filter is injected or it's not.
Yeah. No. Okay.
Anything else? I'm going to show you, just because we have a little extra time here. If you can see this,
we can.
It might not be too easy to see here. Yeah, okay. Let's see, can I,
Cool.
here, I can make things bigger. So this is what I kind of showed you before. This is an API definition, right? And now I want to set up a gold and a silver. So I'm going to say, I'll show you silver first. So in the silver manifestation, right, I have an issuer that's coming from helloworld.com. That's actually not correct. And I have a destination that's this virtual service that I set up
Okay,
to Hello World.
Gold. So is this gold
What's
or silver? I said the name says gold. Is this gold or silver?
Oh, sorry, you're right.
Okay.
Okay, so it's silver. So it's bound to this gateway. It has this api.helloworld.com is the host that we're hitting. This is the target that we want to hit. This is a virtual service that we've set up, and the path. Now, if I instead have a gold level privileges, which means I have this scope that's Hello World Gold. Instead, I want to send it to httbin.com host with a path of headers. So I'm rewriting everything about it. And that's really basically what I said there. We also potentially have the inject response header, which looks exactly like what you saw before. So what actually happens? So the operator will set up this gateway. They have to set it up and make sure that those hosts are included so that it can be routed to them. This is the api.helloworld.com is the incoming host, and the other two are outgoing hosts. They have to actually set up, the Hello World itself. It's just simple, deployment service. This is straight out of the examples from Istio. Same with HTTP bin. HTTP bin is the same thing. It's a deployment and service. What I've set up is a couple of virtual services. So I set up this virtual service to be accessible from the gateway. It's the and to the mesh, in fact. So this is that Hello World VS, and obviously this is its name. You have to use a fully qualified name in Istio for routing like that. And where it matches hello and goes to Hello World. HTTP bin is the same thing. Basically it's a standard virtual service, only I'm saying it's going to be called at this host. And then authentication is set up. And in this case, we have the targets. So for it to, especially for right now, for it to work, I actually have this working as a prototype, but I use headers everywhere. So especially for it to work for headers, I must do the claims work on the target as well. But the benefit of doing that is if I'm doing it both on the gateway and at the target, then it works intra-mesh as well as through the gateway, which is pretty cool. So once I have that set up, basically what would get generated then is going to be something like, so this is the policy, and which is exactly what we saw a second ago. In fact, actually there'd be two policies. This is one of the policies. Assume there would be a Hello World Silver as well, because I included it in both of the API manifestations. And then the virtual service that we talked about would look basically like this. There's API world hello.com. It's on the gateway. It's available in the mesh at this host, and it routes hello to nowhere. And then the way it works is the way I have it working right now. I'll just show you. It's just Lua scripts, but this is just a very simple mechanism. So this is the classification bit, and I'm just hard coding this for now. But I basically check the authority, the path, the issuer, and scopes, and I'm creating headers for these things instead of attributes for gold and silver. So I have a hello world gold here, I have a hello world silver here. So that gets added to the headers. Then in the destination part, I'm saying, okay, well, now I have these attributes, these headers, and I just check silver, gold, and I replace the authority, replace the path, and on it goes. It's pretty straightforward. And in fact, will work. So what I've done right here, oops, let me go to my README. I've gone up to the point where the operator has set up all this information. So if I take HTTP bin works, and the hello world works as straight through. So these are straight to the virtual services, right? However, if I look at helloworld.com API stuff, it says 404. Yeah, it doesn't know anything about that. Okay, so what we want to do is go ahead and we're going to apply the authentication. Oops, wrong window. Increase that. We're going to play the authentication. And then once we do that, we're going to start. Oops. Probably only applied it for the other one. I'm going to apply these manifestation generated stuff. So these are the filters that I just showed you. Okay. And then you should see here, service unavailable. We're concerned that something may have gone wrong. So this is a token. Let me show you what a token might look like. It just has, basic information. I'm just using the Apogee to generate this token. And it's part of it, so I also show you the gold. I'll show you how it's different real quick. The difference is we have, oops, should have scopes, yeah, okay, scopes. And we have the claim that I said would be the difference between the silver and gold. Not going to work because it should be in the, oops. Oh yeah, okay, it is going to work. Okay, so there's gold and there's silver, and that's basically it. There's no difference other than your authentication, and it's sending you a completely different place. It's providing different attributes, so those will be reported in telemetry and can be checked in policy, and voila, as they say.
In the real system, are there headers you would expect to add to send to the application?
That is a good question. So right now, if you do it the way I did it, we can do it through. We don't have to send headers because it actually checks the JOT in both places, right? And even if it's coming through the gateway, it just automatically gets forwarded, and so it's available at the destination as well. And so it can go and check the JOT again and get the claims that it needs. There is no mechanism right now in Istio to securely deliver anything from the gateway to the destination. So this is the only safe way to do it, is to actually evaluate the JOT both places.
Yeah.
And as I said, it's also available that way to intra-mesh. So if you have service-to-service stuff, you can use the same APIs and it will enforce the same information, which is, like I said, a pretty cool feature.
Yeah.
We've talked about kind of what it might take to securely pass attributes along from the gateway to the destination, but there's no hard policy that's been submitted at this point on that.
I just saw today's got a PR to enhance tests around tunneling. Well, maybe it'll just be there.
Maybe if it's just there, that would be cool, and that would give another option to the operator. But as I said, this works now, just by enforcing, just saying that you have to have the authentication there.
That's cool. It's definitely a much simpler overall model than
it was. Yeah. Yes, it is. I mean, and part of that is the authorization is much simpler.
Yeah.
Which I like, because it's just a gateway. It's just gated, as opposed to having to declare a set of APIs, that have to come through in claims. That's a big simplification, because it means that you can use any rules you want to determine which APIs to use.
Yeah.
The other biggest simplification of it was to punt on the authorization and say that's part of the Istio operator's job. But I think that's fair.
Yeah.
It really is. So.
Right. Anybody else got anything to add?
No. All right. Well, the document's out there. Have a link to it in the show notes, and yeah, let me know any feedback.
All right. Thanks a lot. Catch you later.
All right. Thank you.